So yesterday we finished off the class, and I don't know, did we get all of this data entered for the circumference stuff? Okay, how many people have the graph already built for diameter and circumference? Okay, I'm going to give you a couple minutes to get that built, and then we're going to walk through, okay, doing these calculations here. They're more y equals mx plus b type of calculations. Okay, now, I saw that when a few people built this graph, they got a more accurate like equation of a line here. Okay, the one I saw I think was 3.14x plus it was like 1.52 times 10 to the minus 5, which I like a lot better than the equation it spit out when I did it. Okay, because that's a lot closer to pi, and the y-intercept is a lot closer to 0. Why should the y-intercept be effectively 0 for this graph? Right, if I have a diameter of 0, do I have a circle? No, I have a point. Okay, so there's no circumference if I have a diameter of 0. So yeah, because Google Sheets rounds this off a little bit, okay, we don't get a y-intercept of exactly 0 like we should. Okay, but we also don't have the true slope here. The true slope would be a never-ending number because that's what pi is. All right, so if we want to do our calculations here, okay, we want to find the circumference of a circle that has a diameter of 0.88 meters. All right, which axis is circumference on? The y-axis. So what am I solving for here? Y. Okay. So I have y equals m times x plus b. I'm given m, it's 3.14. I'm given x, it's 0.88 meters, because meters is diameter and it's on the x-axis. And I have b. So all I have to do then is plug in my numbers, okay, and I will have my proper answer here. So we will have 3.14 times 0.88 plus 1.52 negative 5. All right, so we're getting a circumference then of 2.76 meters. Okay, now, if this was a unit exam or a quiz or something like that, okay, what I would give you is a graph with the equation on it and ask you exactly these kinds of questions. Okay, it would probably be about position versus time or velocity versus time graphs, because those will be the ones that are most important for us, but we're not there yet. Okay, second question wants us to calculate the diameter of a circle whose circumference is 41.5 meters. What did they give me there? Y, X? They give me y value. All right, so I'm solving for x. All right, so I'm going to solve for x. I'm going to subtract b. So I'll have y minus b, and then I'll divide by m, and that will leave me with x. Okay, so we're looking at 41.5 minus 1.52 times 10 to the minus 5 divided by 3.14. Okay, why did I use all those brackets? All right, I have to take order of operations out of this. Okay, if I don't enclose the top in brackets, it'll divide the other number. It'll divide the numbers first and then subtract from 41.5. Okay, so it would have a diameter of 13.2 meters. All right, questions on those two? You okay with those? Then. Okay. Let's have you guys try this one. Length of rubber band, and I think the next one is one where we have multiple things to graph on the same graph. So we'll look at building that graph together. Okay. I want you guys to build this graph and then see if you can answer those questions. Then I'll go over them. Okay. So let's see how we do on all of that. So I think what we're finding here is that I might have made a mistake with the numbers. Okay. If you're looking at your equation, I don't think. Yeah, so it's looking like this, and I must have screwed up the numbers, and I didn't notice it when I built the graph. But my y-intercept is negative, okay? Which is weird because I can't have a negative length of a rubber band. Like a rubber band can't be less than 0 centimeters in length. Okay, so I must have messed up one of the numbers. So question number 3 isn't going to make much sense because, well, I screwed up a number somewhere. Okay, we can still do questions 1 and 2 because they're just math, but yeah, question number 3, obviously I messed up a number somewhere.
3 be 6.5 just because you're not stretching it at all.
Well, that's what the data says, but the graph doesn't say that, and that's the problem, right? Is the data says this, but the graph says otherwise. Okay, so how long will the rubber band be if it's stretched with 15 newtons worth of force? And so if we're looking here, okay, we've got our length of our rubber band on the x-axis, okay, and we've got our stretching force here. So did they give us a y or an x value there? Okay, they gave us a y value. Okay, 15 newtons. All right, so we're going to plug that in for y, and we're going to solve for x. So x will equal y minus b over m. All right, that'll be 15 newtons minus negative 3.25 divided by 0.5. Okay, so when we do that, 15 minus negative 3.25 divided by 0.5, right, this gives us 36.5 centimeters as our length. Okay, everybody all right with that? And then for question number 2, what force is needed to stretch the rubber band to a length of 18.7 centimeters? All right, so not going to be a whole lot different because we just calculated that the length, oh no, sorry, that's different. Okay, so we've got x here. We're given x is 18.7 centimeters. So we're just calculating y this time. So that'll be 0.5 times 18.7 plus negative 3.25. Okay, plug that in and we'll have our stretching force. So 0.5 times 18.7 minus 3.25. Okay, so we should have 6.1 newtons worth of stretching force. Questions on those two? Okay. All right, so we're going to build this graph now. Okay, so I want you to put in this data, and then I'll show you how to build the graph that has multiple things on it. Because I am seeing that a few people are having an issue come up where Google Sheets is not giving them an x-axis and is putting both sets of data on as points. And so I'll address how that can be fixed if that's happening to you, because it'll probably happen when you build this one. All right, so I'll give you a few minutes to get this data in, okay, and then we'll look at building it. So we've got multiple runs here that we need to graph. Okay, and what we're graphing is the position of a cart, so where the cart is at various points in time. All right, so we're just going to highlight all of it. We're going to insert our chart, same as before. Okay, and it actually picked the right thing, so it actually looks right here. Okay, we've got time on the x-axis. We've got position on the y-axis. It didn't title those, so we will need to fix that. So we'll go to Customize and make sure that we get our proper titles in there. In fact, I'm going to change the title here, okay, so that it's not position cart 1, blah, 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 okay, that it is position versus time. For carts, okay? And then I'll make sure that I've got my vertical axis title, okay, so the y-axis, that's the position, meters. Okay, would you lose marks on a graph if you didn't have those?
Yes.
Yes, you would. Okay. Then I'm going to go to series, because I'm going to need, obviously, the trend line for each one. Right now, it usually defaults here, where it says series, it says apply to all series. Okay, that means usually that's the default, so anything you click will apply to all 3 sets of data there. So if I click trend line, I get a trend line for each cart. Okay? And then obviously I want the equation, so I go down here to label, use equation, okay, and it'll pop the legend over to the side, which probably makes more sense. Right, so now I've got my graph built, okay, and I've got my equations for each line. Right with me there. Okay. So I'm just going to copy this over. Got it. And then we'll look at these questions. Okay, so it wants us to calculate the velocity of each cart. Now that's probably the tricky part because a few people have already come up and said to me, well, Mr. Coderre, if I take the data, okay, so if I take this data and I divide like 1.5 by 1 and 2.7 by 2, I don't get the same answer, okay, taking like displacement divided by time. I don't get the same answer for each one. You're right, okay? And that's usually what happens when you do a lab where you're recording position and time. The cart doesn't always travel at exactly a constant velocity. It's kind of up and down a little bit. Okay, that's why we want to make a graph of it, because it will average those out when it builds the trend line. Okay, what we want to do with the trend line is use it to get our average velocity. We've been doing questions where we calculate average velocity in class. Average velocity is the total displacement, okay, divided by the total time. Okay, if we do that, though, that's really just taking the last number and dividing by this one. Okay, what Google Sheets does is it takes into account all of the points. Okay, its average is much more accurate because it's weighting them all equally. You kind of follow me on that? Okay, so what I end up with, okay, is that the slope of these lines is actually the velocity of the cart. Here's why. Okay, if I'm looking at this formula here, to calculate the total displacement, I take my final position and I subtract my initial position. Right? Because that's what displacement is, right? It's the straight line distance from final position to initial position. And then I divide by time. All right. When I solve this equation for slope, I subtract b, and then I divide by x. Does that look a lot like this formula? That's because it is that formula. Look what's on my graph. What's on the y-axis? Position. Final position minus initial position over, what's on the x-axis? Time. Okay, that's where that formula comes from. It calculates the slope of the line on a position time graph. See how physics is cool because it always works? All right, so let's have a look at, so let's calculate the velocity for each cart. It's kind of misleading because you actually don't have to calculate it. It's right there. You know how many times I put that on my Unit 1 Physics 20 exam? And people get it wrong? They got to go through all these long calculations, okay? And I have a graph just like this on there with that. And I say, calculate the velocity, and they show 5 marks worth of work for a 1 mark question. Okay? The first cart's moving at 1.38 meters per second. Second one, 2.01 meters per second. Third one, 3.39 meters per second. Okay? All right. The position of each cart after 12 seconds. Am I solving for an X or a Y there? Y. Position's on the Y-axis. All right, so we want to find the position of each cart after 12 seconds. I'm just going to erase this stuff here. We'll do that calculation right here. Okay, so the Y value for cart 1, okay, that's going to be 1.38 times 12 seconds plus 9.52 times 10 to the minus 3. .38 times 12 plus 0.00952. Okay, so my position after 12 seconds for cart 1 is going to be 16.6 meters. Okay, after 12 seconds for cart 2, 2.01 times 12 plus negative 0.0524. All right, so our position there is going to be 24.1 meters. And these should both be positive because it's asking for position, which is actually a vector quantity. Okay, and then Y3, and we're going to have 3.39 times 12 plus 0.0381. All right, so its position after 12 seconds will be 40.7 meters. Okay, everybody all right with that? Okay. How many people have done question number 3? All right, I'm going to give you some time to do that. You're solving for how long it will take each of them to reach a position of 50 meters. All right, so in number 3, we're looking to solve for an x value because they gave us 50 meters, which is a position, that's a y value. Okay, so when we manipulate, we're going to have that x equals y minus b over m. Okay, so for cart number 1, that's going to be 50 meters minus 0.00952, okay, divided by 1.38. 50 minus 0.00952, okay, divided by 1.38. So it's going to take that cart 36.2 seconds, okay, to get to 50 meters. Okay, for cart number 2, okay, we're going to have 50 minus minus negative 0.0524 divided by 2.01. Okay, so we're getting 24.9 seconds for that one. And then for the cart number 3, 50 minus 0.0381 divided by 3.39. Okay, and we should notice that as the carts are getting faster, the times are getting smaller. Right? 50 minus 0.0381 okay, divided by 3.39. 14.7 seconds. Okay, on Monday, we're going to be doing a lab to do with position versus time graphs. All right, we're going to run some carts down the atrium, and we're going to measure how fast, what position they're in after various points in time. We're going to build some graphs, do some calculations, okay, things like that. So, you ready for that on Monday?